Hello everyone, I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to discuss how to find optimum solution for the transportation problem using MODI method, which is called as Modified Distribution Method. So, this is the solution which we have obtained using VAM technique. So, this is initial basic feasible solution which we have obtained using Ogle's approximation method. Now, we have to check whether this IBFS is optimum solution or not. So, using MODI method, we can check whether this initial basic feasible solution is optimum or not using net evaluations called Dij. So, by computing Dij values, we can find out whether this IBFS is optimum or not. If all the Dijs are greater than or equal to 0, then we can consider that the IBFS is optimum solution. So, in order to compute these Dij values, we want Ui and Vj values. And how we can find out these Ui, Vj values? Using this formula, we can compute, that is Cij is equal to Ui plus Vj. Using this formula, we can compute Ui and Vj values which are required to compute net evaluations, that is Dij. So, let me tell you how to calculate these Ui, Vj values. So, in order to start the computation process, we have to start the computation of Ui, Vj values from that row or that column which has maximum number of allocations. If we look at the rows are having only 2 allocations. If we screen the columns, first column, second column, third column are having 1 allocation and fourth column is having 3 allocations. Therefore, we can start with V4 by considering V4 as 0. These are called Ui values, that is, it is U1, U2, U3, and these are called Vj values, V1, V2, V3, V4. So, column 4 is having maximum allocations. Therefore, let us start with column 4 by considering V4 as 0. This is how we start the computation process of Vi and Vj values. So, and remember, these computations are to be done only for occupied cells. What do you mean by occupied cells? The cells with allocations. So, those cells are called occupied cells. For occupied cells only, we have to compute these Ui, Vj values. Okay. Therefore, let us consider this cell C14. So, for C14, the formula is U1 plus V4. V4 we have considered as 0 and the value of C14 is 10. Okay. So, substitute that value here, that is U1 is equal to 10 minus 0, therefore, U1 value is 10. So, likewise, so U1 is 10 and the next cell we can consider is C11. So, that is this one, C11. So, the value is 19. Since we have obtained U1 value, therefore, you can compute V1 value using this value. Therefore, let us compute V1 value using C11, right. Therefore, C11 formula is U1 plus V1 and U1 we have already obtained as 10 and the value in C11 is 19. So, 19 minus 10 gives 9. So, this is how we have to compute all the Ui, Vj values, that is U1, U2, U3, V1, V2, V3, V4 using occupied cells, and also using this formula we can obtain all these values in this way. Okay. And after obtaining all these values, next we have to compute net evaluations using this formula. Okay. And remember, net evaluations should be done only for unoccupied cells. What are unoccupied cells? The cells with no allocations. So, these are the cells which are ticked are unoccupied cells. Okay. So, for unoccupied cells only, we have to perform these net evaluations, right. So, the first unoccupied cell is this one, that is C12. Okay. So, for C12 we have to perform the net evaluation, that is D12, first one. So, the formula for D12 is C12 minus U1 plus V2. Okay. Using this formula we can obtain D12 value as 32. Likewise, for all unoccupied cells we have to find out these Dij values in this model. Okay. Now, we have obtained all the Dij values. So, based upon these Dij values, that is nothing but net evaluations. So, if the net evaluations, all the net evaluations are greater than or equal to 0, then we say this solution, this initial basic feasible solution is optimum. If at least one value, one Dij is negative, then it is termed, it is not considered as optimum solution, and we have to move to the next iteration. So, let us look at the Dij values. So, there is one negative value. Therefore, one Dij is negative. Therefore, initial basic feasible solution is not optimum solution. Therefore, we have to proceed to next iteration, that is first iteration what we call. Okay. Therefore, here we have to consider which cell is, which unoccupied cell has minimum negative value, that is among all the Dijs, which is most negative, that is this one D22. Therefore, we have to create a closed loop or closed path starting from unoccupied cell. And among the unoccupied cells, from which cell we have to start? We have to consider that cell which is having most negative or least value. Okay. So, D22, that is cell 22 is having least value, right, 22, this one. Okay. And this is C22, right. From this unoccupied cell we have to create the closed path, and from this unoccupied cell 2 we have to move to the next occupied cell, that is this one, right. Now, you may have doubt, why not this particular C13, why to C14? Because if we move on from up to C13, next we have to move from this unoccupied cell to, we have to move to the next occupied cell. From this occupied cell there is no other occupied cell. Therefore, we have to move to, from this unoccupied cell to this occupied cell only we have to move, not to this one, because this column is not at all having the occupied cells to take the next turn, right. Therefore, from this to this, and from this cell to next occupied one is this one, from this to next occupied is this one, from this next occupied is this one. So, this is how we have to form the closed loop, and after forming the closed loop, for the corners of the loop assign plus or minus signs alternatively starting from the unoccupied cell. Okay. So, here it is plus, next minus, next plus, next minus. So, this is how we have to assign plus or minus signs to the corner points of the loop, and after that observe which value is most minimum among the between the corners having minus sign. So, here we have only, in the closed loop we have only two corner points with minus sign. Among those two, 2 is very small. So, here 2, here 8, and between these two values 2 is less. Therefore, 2 must be added to the corners which are having plus sign, must be subtracted to the at the corner points which are having minus, and the other values should be kept as the same, right. So, here it is 30. So, 30 minus 2, therefore, we have considered the minimum value 2. This 2 must be subtracted from the corners having minus sign and should be added to the corners which are having plus. Therefore, this unoccupied cell will become occupied 2. Okay, since here initially there is no allocation, therefore we consider it as 0. 0 plus 2, 2. Therefore, 2, and for this corner we will subtract 2. 2 minus 2, 0. Therefore, this occupied cell will become unoccupied. And then here we have to add 2. Therefore, this 10 will become 12. And here we have 8 and the sign we have assigned here is minus. Therefore, 8 minus 2 is going to be 6. So, this is using this value closed loop. We have to move on to the next iteration. So, after this again we have to find. Now, these are the new allocations which we have got for the next iteration. Now, we have to check whether this solution is optimum or not. Again, how we have computed ui vj values, likewise again we have to compute ui vj values. So, these are ui and these are vj, u1, u2, u3, v1, v2, v3, v4. So, here all the columns are having 2 allocations. So, randomly any occupied cells, you have to remember only for using occupied cells we have to compute ui vj values, right. So, select any occupied cell. C11 is occupied, you can select that one. So, C11, if we consider C11 and consider u1 as 0, that is u1 as 0, then v1 value is going to be 19. Okay, like this compute ui vj values using all occupied cells, right. And then again after obtaining ui vj values like this, in the second iteration again compute dij values, that is net evaluations, is using these new ui vj values. Now, after computing dij values, again look at all the dij values, whether any dij is negative or all the dijs are positive or that is greater than or equal to 0. If all the net evaluations are greater than or equal to 0, the solution is going to be optimum. If at least one dij is negative, then solution is not going to be optimum. Again we have to move to the next iteration. So, here all the dijs are positive. Therefore, the solution we have reached optimum solution. Okay. And the optimum. So, these are the allocations which we have obtained. Therefore, all the dijs are positive. We have arrived the optimum solution and this is the optimum solution. So, for C11 the allocation is 5. Therefore, 19 into 5 plus, and for this cell the allocation is 2, that is 2 units are to be supplied and the cost of transportation for 2 units from S1 to D4 is 10. Therefore, 10 into 2, and here the allocation is 2, that is from S2 to D2 destination 2 units are to be supplied and cost of transportation is 30. This is how we have to compute the total minimum transportation cost, and which is 743 rupees. So, this is how we can find out total minimum transportation cost, and also we can, using Modi method, we can find out how many units are to be transported or supplied from each source to each destination, so as to minimize the total transportation cost using Modi method. Therefore, by the end of this lecture, we have understood that how to test whether the IBFS is optimum or not. If it is not optimum solution, how to compute ui vj values, how to calculate net evaluations, and how to check whether the solution is optimum or not, and all these, and how to compute the total minimum transportation cost we have learned by the end of this lecture. Thank you.